any given day, I'm serving as a professor and I'm mentoring my students and my postdocs. But I also am a Energy Frontier Research Center director. And so I'm sitting on calls with other people's students and postdocs, and we're asking questions and we're talking about data. I attend conferences where I'm presenting our work. I'm running an energy justice panel at the Arizona Student Energy Conference. I serve as co-director for the Institute of Energy Solutions, and I have a joint appointment with the National Renewable Energy Laboratory. And so at any given day, I don't fully know where I'm going and what's going on unless my calendar says where I need to go. Describe myself as an electrochemist and an interface scientist. So electrochemistry is really quite ubiquitous across a variety of different disciplines. It's involved in how our neurons transmit signals with one another. It's involved in solar cells and the fundamental processes of converting sunlight into electricity. And so you can take these different perspectives from one area or one field and then apply it in a new way to create new types of printable electronic devices. Is it something where our conductor can be put inside of an inkjet printer? Is it something that the same technology that's used to make potato chip bags, which are really just 80 very, very thin layers put together for different functionalities? That's what we think about when we think about printable. So in 2022, the University of Arizona received the lead for a soft photoelectrochemical systems Energy Frontier Research Center. Our center spans across 8 institutions for $10.95 million, which was awarded by the Department of Energy. And so what we're working on is next generation systems that could be at meters scale for hydrogen production, could be batteries that could be printed very, very quickly, but also would have applications to things like bioelectronics, healthcare, retina replacements, all sorts of different applications.
It's actually pretty amazing that she's head of this Engineering Frontiers Energy Center, because most of the time, the types of centers that she's running, that Erin is running, are not led by associate professors at the time in their career that she is. She has Regents professors working with her, top scientists at Georgia Tech at the National Renewable Energy Lab, and she's the PI, the principal investigator for all of this. This just isn't normal.
I grew up on a hobby farm, which to me means manual labor for fun on the weekends. My mom is a food scientist, made cheese and ice cream, and my dad was a professor in agricultural economics. And so they were very supportive of really anything that I wanted to do, very encouraging. When I was younger, I used to make super soap. I would take all of the soaps and mix them together, which really just meant I made a super surfactant. So when I was young, I spilled it on the floor. And in Wisconsin, the summers get quite humid, so then the carpet would bubble from my super soap concoction that I'd made.
Did you get in trouble for that?
Oh yes, I absolutely got in trouble. How do you clean up super soap though?
So I was introduced to Erin Ratcliff primarily through her mentor, Neil Armstrong. Neil and I were working on alternative energy initiatives on campus. So we were forming an institute, the Institute for Energy Solutions. And through that process, he's like, you've got to meet this person that works with me, Erin Ratcliff.
I knew in the first couple of weeks that she was going to be different than most of the postdocs that I had had. She was not only doing very high-level science in my group and mentoring students at the same time, but she was taking notes on how big multidisciplinary science centers are organized, how you get those proposals funded, et cetera. She was very actively involved in thinking about the big science that we would be doing, but also in engaging with some of the partners some of whom are now on the EFRC that she's currently running. boy, she fit like a glove into that kind of system.
I was really the person that went to all of the different institutions and did a lot of the research coordination. Or would come up with hypotheses, and I knew what everybody else was doing in the center, and so I could go to a student at NREL, and we could work on the solar cell, and then I could go out to Princeton to do some spectroscopy, and I could go to University of Washington to do some microscopy. And so from that, we were able to stitch together and accelerate the pace of our science and bring everything together. So in 2019, I received an Energy Frontier Research Center 10 at 10 award. It was the 10-year anniversary of the initial Energy Frontier Research Centers.
There was a big celebration in Washington, D.C., which we both went to for this 10th anniversary of the EFRC program. And again, if we had been thinking, it was natural that she was then going to wind up directing an Energy Frontier Research Center, right? I mean, she was hardwired for this. So, and DOE knew it.
Professor Ratcliff is, in my opinion, an amazing teacher because I have always been able to go to her when I've had specific questions, whether it's a research question or a more kind of fundamental knowledge question. Being able to just take that time out of her already really busy day to sit down with me and help me through the fundamentals has been something that, again, has really helped in my student development.
I really do like working with my students and with other people's students. They ask questions that make you think, right? And that's what I really enjoy about my job is that's a question that I hadn't thought about in that way, in the way that it was posed. And so even the times where you get these questions from students in the classroom, you say, I don't know the answer to that right now, but I'm gonna go back and I'm gonna find out and we're gonna talk about it next time. That's a lot of fun, is that I like learning new things. And so when I get pushed by my students and my postdocs to think about things in new ways, it changes my perspective as well as theirs.
She really cares about her students and her work, and so this is a passion that is almost contagious. Because of how much she cares, it makes doing the work a lot of fun.
She also brings a sensitivity to diversity, equity, and inclusion issues that are now need to be integrated into all that we do in these research fields. And I think that's a transformative change.
Absolutely, a diversity of perspectives is very important for what we do. Everybody thinks about challenges and problems differently, and so what you learn from system A and then apply to system B, for example, gives you this whole new perspective.
It's fantastic science, it's cutting edge, it's high impact, it's high risk, but it's also integrated nicely with a sensitivity to broadening participation that we didn't have a few decades ago.
The Da Vinci Award is a huge honor. I'm so thrilled to have been selected. I'm among some very prestigious peers at the University of Arizona.
She fits the mold. I mean, she is novel, she has a huge network, she publishes amazing papers, she's leading centers. You know, she just fits the mold of what the Da Vinci Fellow is.
I plan to use the award to fund all of my students and postdocs to go to a prestigious conference in North Carolina this summer. So I wouldn't normally be able to take everybody all at once, but with the funds, I'm able to take everybody together.
When you're not doing all of that, what do you do for fun?
Sleep. But what do I do for fun? I have a 5-year-old, so he keeps me young. This morning we were playing Avengers. I was Captain America.